the degree is telling us how many zeros we will have. What's the maximum number of zeros we could have for x cubed minus 1? 3. Okay. Now, we could have 1 0 that happens 3 times. We could have 3 different ones. So I'm going to graph this, and we're going to look to see how many zeros there are. And we look at a graph, and how many zeros do you see? 1. Does it happen 3 times? If this 0 occurred 3 times, I'm going to just open up a blank one again. If it occurred 3 times, let's talk about multiplicity. If it occurred 3 times, right at that number, there would be a cubic behavior right at that 0 if it happened multiple times, where this just passes through. Just like if it happened twice, and it doesn't happen twice there, but if it happened twice at that 0, it would be like a bounce, right? If it happened 3 times, it would have this point of inflection where it would change its concavity from down to up, but it doesn't have that. There's only 1 0 at x equals 1. So where are the other 2? They are imaginary. You can't see them because they are imaginary. Good job. So with Descartes' rule of signs, we are going to determine how many positive, as in the right side of the x-axis, how many positive possible roots there are. Possible, because it's not going to tell us exactly how many negative possible roots there could be. And then the third thing we will determine is how many imaginary roots there could be, because there could be ones that we can't see, imaginary roots. So Descartes' rule of signs starts with this. We're going to look at the given equation, and we're going to go from left to right, and we're going to look for sign variations. That's where it changes from plus to minus or minus to plus. So I'm just going to go from left to right, and I'm going to start with a positive x to the 6th, and then I'm going to go to a negative 2 x to the 5th. That is a sign variation. That is a sign change. Then negative 2 to positive 3, that's a sign change. Positive 3 to negative 10, what do you think? Sign change. How about negative 10 to negative 6? No. Negative 6, negative 8? Nah. Negative 8 to negative 8? No. Those are not sign changes. So we have a total of 3 sign changes. What that means is we have a maximum number of 3 positive zeros. A maximum number of 3 positive zeros. When I do graph this maximum, there's going to be 3 over here. There could be less, but maximum there's going to be 3 positive zeros. How many zeros will there be total? There's going to be 6, right? Our degree is 6. So there will be 6 total zeros. Maximum 3 of them are going to be positive. So now we're going to do possible negative roots. To find possible negative roots, you change all of your x's to negative x. So this is the exact same equation as before, only every single x is now negative x. We have a teeny bit of simplifying to do. If I take a negative x to an even exponent, what happens to the negative if I take it to an even exponent? It's positive. So this is going to be positive. Here I've got a negative x to a negative exponent. So that will be a negative when it's done. So this will end up being a negative 2 times the negative, so positive 2x to the 5th. And then this one here, I've got a negative x to a even, so it's going to be positive, and that doesn't change the sign of the 3. Here I've got a negative 10, and then I have a negative x to the 3rd. So two negatives together makes a positive. I've got a negative 6 and I've got a negative x squared. Negative x squared is positive. So that stays negative x. Chris, will you shut that, please? Thank you. Appreciate it. Our last one is a negative x, and then we've got, a negative 8 and a negative x, which becomes a positive 8, and then our minus 8 at the end. So we plugged in negative x for all the x's and we simplified, and then we're going to look for sign changes again. So for the first to second terms, they're both positive, no sign change. Another positive, no sign change. Another positive, no sign change. But then I've got positive 10 to negative 6, that's a sign change. Negative 6 to positive 8, that's a sign change. And then positive 8 to negative 8, that's a sign change. So we have how many total sign changes? 3 sign changes. So that's going to tell us that there are 3 maximum negative zeros. So in the graph, there's a maximum of 3 negatives. There could be less, but there's a maximum of 3 negatives. Now, before I go on, what is imaginary? What is that? Remember, it's an I? Anybody know how I get an I? Square root of negative 1. That's the definition of what an imaginary number is, the square root of negative 1. If I had something like the square root of negative 3, I could break that down to be the square root of negative 1 and the square root of 3, which would give me I square root 3. If I am solving an equation, x squared equals negative 4, I square root both sides. Please tell me what I have to do when I square root. I have to do plus minus. So I've got plus minus square root negative 4. That's going to be a square root of a negative 1 and a square root of a 4. So I get plus minus 2i. All right. So that you did a bunch in algebra 2. It's coming back again. The biggest thing that I want you to understand is when we are solving, you're always going to get a plus minus with an I value because it is a square root. So square roots always come in pairs with answers. So to imaginary numbers, they only come with plus minus pairs. They always come in pairs. You won't ever have one imaginary number. You'll have 2 or 4 or 6. They come in pairs. When you're solving. So I'm going to make this table at the bottom. And this table is going to help us find every possible scenario that we could have for this question. I knew that there were 3 positive, and these were the maximum numbers. 3 positive and 3 negative. Those were the maximum numbers. I also know that my final degree is 6. If I add together the 3 positive and 3 negative, that leaves me with 0 imaginary numbers to equal 6 total zeros. But that's the maximum. So we could have less positive and less negative because we could have some imaginary numbers. So what I'm going to do is I'm going to add in the imaginaries first. It still has to add up to equal 6. Can I add one imaginary number? Robbie, why not? Because they come in pairs. So I'm only allowed to add 2 or 4 or 6 or 10 or 12 or 8. So I'm going to add 2. If I have 2 imaginary, let's say I have 3 positive still, that leaves me with how many negatives? 1 to equal 6 total. We're always going to equal 6. These are different scenarios that we could possibly have. What if I had 2 imaginary? Could I have 3 negative? That would leave me with how many positive? 1. Okay, that would work. Is there another scenario, let's see, where I could have 1 positive? I see 2 scenarios where I have 2 positives, or 3 positives. Yeah. What do you think? We could have 4 imaginary. Yep. 1 positive, 1 negative. What's another scenario that we could possibly have? Or did we find them all? Dylan, do you know another one? Because you said no, I didn't find them all. 2, 2, and 2. That'd work, right? That equals 6. My imaginaries have to be even. That works. Nico? Say it, 6 imaginary? Yeah. So what would be my all the way across what? Yep, we could have that. I think that might be it. So you just want to list all the different possibilities that you could have. Now, if I went ahead and solved this one, which I'm not going to do, but if I went ahead and I solved this one and we found that our zeros were 1, 2, 3, 4, and then let's say plus minus 2i. Let's say that was my answers. Could that have been my correct answers? No, Evan? Yeah. Why not? Because the maximum positives is 3 and I have 4 positives. So that tells me I'm doing something wrong. So this is like another thing that we can check to make sure we're doing everything correct. Other than that, we're not going to use this table for anything higher level other than can you create it? Can you use it to maybe check your answers? That's the most that we're going to do with this table. So we've got 2 examples to do together where we're actually going to find the zeros. We're going to use Descartes' rule of signs to find the possible positive, negative, imaginary zeros for the function, and then we're going to find all of our zeros. So we've got x cubed minus 1. Oh, that sounds familiar. Like we just saw that one, maybe. So I'm going to start with my positives. To do the positives, we just look at sign changes in the original question. So I've got x cubed minus 1. If I put the zeros in, zeros aren't sign changes. So if you actually put the zeros in to do this, you're not wasting your time, but you're kind of wasting your time because they don't count for sign changes. This is positive and this is negative. There's 1 sign change. So we've got maximum for positives, 1. And when we add them all up, what is the degree for this one? What does it have to equal? 3. Okay. So now we're going to do our negatives. To do the negatives, we do g of negative x. So we take all of our x's and we change them into negative x. And then I just need to simplify. Negative x cubed is negative x cubed. So how many sign changes? Goes from negative to negative. So that is a maximum of 0. There are no negative, there's no possibility of a negative 0. So if I have 1 positive and 0 negative, how many imaginary would I have to have? 2. So now, is there another scenario that would equal 3? Yeah, Blake. Blake suggests, how about 0, 0, 3? And you guys are going to tell him what? Why not, Liam? Because 3 is not even, and the imaginaries have to be even. Any other scenarios we could have? What about 0, 1, 2? Why not? Because the maximum negatives is 0. So there's just no other scenarios. That's it. That's what it has to be. That's the one we already graphed. So at this point, you're going to graph it. You're going to look at the graph, and you're going to say, oh, 1 is a 0. Oops. What do we do if 1 is a 0? Stuff we did on our last assignment. What do we do if 1 is a 0? Do what? Oh, synthetic division. Yeah. So we'll do synthetic division. We do need to put placeholders in for those zeros for synthetic division. And we get x squared plus x plus 1. So if the rest of the answers are imaginary, you aren't going to be able to factor it. You are going to have to use quadratic formula or complete the square. So I'll go ahead and use quadratic formula. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. So I get negative 1 plus or minus I square root 3 over 2. Or you could write it, some of you like to separate it, you could write it as negative 1/2 plus or minus square root 3 over 2, and then the I would be at the end of it. Now, this is asking us to just write, and this is what your homework tonight, or your assignment, is just going to ask you for the zeros. You do not have to put it back in factored form, because I know that's like a lot of extra steps. So we're just going to do the zeros. I will always put the real zeros first, and then I'll put the imaginaries after that. When I go to put them in order, that's the order that I'll use. So that's all you have to do for today's assignment. You don't have to put it in factored form. All right, one more. You guys are going to help a little bit more with this one. We're going to determine the positive, negatives, real, and then we're going to find the zeros. So for positive, we need to look for sign changes from left to right. Luke, how many sign changes we got? 0. That was Luke. That was not Luke. So for negative, we're going to put in negative x. I'm going to simplify. Anytime I have a negative x to the 4th power, it doesn't change the sign. It just becomes positive again. Luke, how many sign changes for negative? 0, yeah. The degree, Todd, what's the degree? 4, good. So we have 0 positive, 0 negative. How many imaginary do we have? 4. Is there another scenario? No, because 0 is the max, so we can't really go down from 0. So this is the situation. So now we need to find some zeros. What should we do? I said we, not me. What should you do? Gotta find some zeros. What should you do? At this point, the work hasn't changed. The only thing new is this table. So what should we do? Dylan? Divide by 4? Why would I divide by 4? Because of the degree? Oh, no. So we want to use synthetic division when we find a 0. So how are we going to find a 0? What? Oh, graph it? Okay. So who's going to graph it? Only Liam, right? Fingers out. Type the equation in. If you have an equation in there you don't want to delete, you can just turn it off. Do you guys know how to turn them off? You just like hit the equal sign and it turns it off. Nico, do you have a question? Yeah. What? It's a good question. What was it? X to the 4th? Was it +1 then? Ah, my bad. Well, the graph's there, but Nico, you are correct. If there's no real x-intercepts, you aren't going to be able to see one. So good job thinking about that before everybody graphed it. You guys are welcome. You're welcome. Thank you, Nico. That's what I meant to say. So yeah, if we don't have any, you aren't going to be able to see it. So what do we do? If you don't have any, you're not out of luck. If you don't have any at all, I will only give you ones that have no visible roots or x-intercepts if it can be factored. That means this must be able to be factored. Again, you are correct. You can't see any of them, so we won't be able to pull out 2 of them. But this is factorable. This is a trinomial, so we'll do guess and check. They're both going to be plus. The 5 at the end tells me 5 and 1. It's like my only options, right? What's going to be in my first spot? X squared and x squared. From here, I can't really factor it further, but I can solve it by setting them equal to 0. And when you square root both sides of an equation, you got to put plus minus. And then when we have a negative underneath the square root, that becomes like square root -1, square root 5. So we've got plus minus I square root 5. And then this one is plus minus just I. And that's 4 imaginary answers. So everything is pretty much the same that you've been doing. Except you don't have to write this one in factored form. You can just stop at the finding the zeros. And this one's going to have imaginaries. We hadn't had imaginary before. By the way, we will eventually write this in factored form, so I'll just do it just for fun. But you don't have to do it in your assignment at all, except for order-wise, I would probably go negative I square root 5, then negative I, then I square root 5. So my factors would be x plus I square root 5, x plus I, x minus I, and x minus I square root 5. So that's the factored form with, I don't know what letter it is, g of x, h of x, what is it? F of x. Yeah. There you go. That's what the factored form would look like. You don't have to do factored form for this assignment, but we will when we do a quiz or a test eventually on this. Okay. All right. So you have the rest of the time to work on finishing up that first assignment, correcting things, or starting the new one.